Hey people, welcome back to Nemesis Tech. So today we are going to talk about undervolting, being pretty much the opposite of overclocking. One does overclocking when you still want more performance and have some thermal headroom. My previous video tells you how to do it. So when do you undervolt? Undervolting helps you when your CPU runs hot. Good examples, and most often the use case for undervolting, are laptops. In comparison to desktop computers, their cooling systems are anemic or as loud as a lawnmower. Desktop computers are often not excluded, as system integrators and first-time builders may choose inappropriate parts for cooling. Either way, it's a compromise that you can try and tilt to your favor. For undervolting, we again are taking advantage of silicon lottery, so results may vary. Just as much as a lottery-winning chip could overclock better than the rest, it can be tamed easier as well. But don't feel discouraged by your luck today, as specs leading to Ryzen's stock performance are unchanged from the less refined early days of its production. Today's chips leave the early ones in the dust and could be all called lottery winners. We are trying to preserve the performance we are used to, but depending on your silicon quality, a small bump in performance may be in it as well. A small disclaimer before we begin. Overclocking and undervolting can cause instability, and I don't recommend either if you're working with sensitive data, at least not without thorough testing with programs like Prime95, Intel Burn Test, and ADA64. Now that we have that out of the way, let's start to undervolt. So for this test, I set my water cooling to 25% pump and fan speed to simulate an insufficient cooling. We simulate a short heavy load and make sure we don't lose any performance in the process. The tools for today are the same as in the overclocking attempt. We have hardware monitor to the right, Ryzen master to the left, and Cinebench R20. To start off, we do a Cinebench run to see where performance is starting out. At this point, make sure to check your temps, voltages and clock speeds under load to know where the trip is headed. Under these conditions, my chip peaks at 85 degrees Celsius, feeding 1.23 to 1.25 volts, while after the boost is over, it stabilizes at 4.05 GHz. My suggestion would be to discard the 4.05 GHz and go to a nicer 4.1 GHz, as that would start us off with a slight performance advantage, and tweak the voltage by going off what yours has presented. The tweak would be started at 1.25 volts in my case, and I will shave 0.05 volts off of that to land at 1.2 volts, at which point we can let Cinebench do its thing. As we can see, while Cinebench is running, the CPU is having a grand time, consuming less energy and producing less heat. The system is running 10 degrees cooler and consuming around 20 watts less compared to stock settings. If we take a look at the voltage, we can see that while we set 1.2 volts, we get only 1.15 volts. This has to do with load line calibration meant to undervolt for you, but at stock settings it was not aggressive enough. Now that Cinebench finished, we just take a quick glance at the score and make sure we did not lose performance. In this case we did not, so we repeat with another voltage decrease. Again, we see the load line do its thing and decrease our voltage even more. At the 1.1 volts we are effectively getting now, the processor is taking 0.15 volts less than stock. That translates to around 25 watts less power and 15 degrees Celsius less heat, as we don't seem to exceed 70 degrees Celsius down from the initial 85. We repeat this process as far as it will go, with the obvious stopping point being performance loss or even a system crash. At this point you probably have asked yourself, how can we lose performance at the set frequency that doesn't change? Well, at some point, while the system may not crash on you, you may see a regression in your Cinebench score. That happens when your system is at the brink of stability and the CPU is struggling to keep going. When you hit this point, you can choose one of two things. You either increase your voltage by 0.025 volts if your temperature allows it, and furthermore may even consider an attempt at overclocking. Or you didn't achieve your thermal goal, in which case you decrease frequency and try again for stability. I can't stress this enough, but as stated in the disclaimer, Cinebench is just the smallest stability test and only used because of its speed and scores. When your thermal goal is achieved, you should test extensively with programs previously mentioned. Two more things. You can apply the same logical steps for Intel processors, though at that point you are obviously not using Ryzen Master but rather XTU, short for Intel Extreme Tuning Utility. And while Ryzen Master and XTU can achieve a more or less permanent result, it is a good measure to apply the found settings in your BIOS if you have access to an extended BIOS. Those are mostly found on desktop PCs rather than laptops. For that, consult your motherboard's manual, as the setting may be called and structured differently from one vendor to the next. And that concludes the video. If you found this helpful, leave a like and consider subscribing. Also leave your successful undervolts or overclocks down in the comment section, as well as anything you would like to see in a future video. Bye bye.